Hello, everybody. Today we are going to be going over 5.4, Unit 5.4. Let's start off with a little bit of review with our bell ring review here. A triangle with no congruent sides is called. Remember, no sides are congruent. We are dealing with a scalene triangle, a triangle with two congruent sides, meaning two sides that are equal, are isosceles. And then finally, the last triangle with all the sides congruent or equal. It's in the name, equilateral. Equilateral, just a fancy word for saying all the sides are congruent or equal. Here we have in this little picture here, remember we have our tick marks? This tick mark shows us that there are two congruent sides here. So we are dealing with an isosceles here. The congruent sides of an isosceles triangle are called the legs. They are called the legs. So here, FD, let me highlight the legs for you here. FD and ED are considered the legs of an isosceles triangle. The non-congruent side is called the base. And in this case, our base, let me highlight that in green, is here on the bottom. Next, the angle formed between the legs of the isosceles triangle. So in between the two legs of the isosceles triangle is the vertex, right? Vertex, okay, angle. So it's considered the vertex angle, and that's the one that's going to be up here, right up here at this tip. So let me mark that here. The vertex angle isn't congruent to anything. It is by itself, but I'll just mark that here as that vertex angle. Well, actually, I don't really need to mark it because it's not congruent to anything. The angles formed between the base and the leg in an isosceles triangle is considered the base angles, or so our base angles are the angles formed between the base and the keyword base, so it has to be on the bottom. So this and this, where the base are, they have one side of it has to be the base, so that is the base angle. And in this case, angle F and angle E are our base angles. Our vertex angle here is angle D. So this is angle F and angle E are considered your base angles. And let me write down what the legs here so we can have that. FD and ED are our legs. Our base is FE. Okay, next one means that it is non-adjacent, not touching, and furthest from. So if it's non-adjacent, not touching, and furthest from, that is considered the opposite. We call that the opposite. So if you think about it, if you look at that picture of our triangle, notice that angle D is opposite, right? It's non-adjacent, not touching, furthest from, is opposite FE. So that vertex angle and our base are opposite from each other. So there, if I drew a little arrow, that would be considered our opposite. Just like other examples, from angle E is opposite the line FD, line segment FD, and angle F is opposite line segment ED. Let's try some of these other examples out dealing with isosceles triangle. So let's look here with this new picture. Triangle ABC. Let's name our legs. Remember, the legs are part of the ones that are congruent to each other. So our legs here are AB. Oh, messed that up a little. Let's try to fix that. Legs here are AB and AC. Those are the legs. Our base here is BC. Our base angles are angle B and angle C. And our vertex angle, the one on top, angle A. Let's talk about opposite sides. Our opposite, angle A, is opposite from BC. Notice here that, that distance, it's on the opposite side. Angle B is opposite AC. Angle C is opposite AB. The line segment from each other. So AB is opposite angle C. BC is opposite angle A. And AC is opposite angle B. So you can write it backwards and forwards just like that. Let's talk about theorem. If two sides of a triangle are congruent, then the angles opposite of them are congruent. This is called our base angle theorem. Base angles theorem. So they're just saying if the sides are congruent, the angles need to be congruent. So the base angles are congruent. The converse of that, of our base angles, so of our base angles, basically theorem says if two angles of the triangle are congruent, then the opposite of them, opposite sides, are congruent. So now the converse is saying, hey, the angles are congruent. That means the sides are congruent. So if I drew a little picture, this first one says this: if the two sides, so here we're going to start out with the sides are congruent, then the base angles have to be congruent. And remember, one with having base angles, though we're dealing with isosceles triangle here. Now here, this saying if the base angles are congruent, then the sides also have to be congruent. Let's go on down here now to do some more examples. We want to, let's see here. It says if, number one, if HG is congruent to HK. So I'm going to put in my markers, my tally markers. So HK and HG are congruent. Then angle G must be congruent to angle K. So G must be congruent to angle K. Number two, if angle KHG is congruent, so let me mark that. Angle KHJ, so I'm going to do that with two tick marks now, is congruent to angle KJH. I'm going to do two tick marks. Let me erase the first part so that maybe I'll just use a different color. Then which two, if now they gave us the angle, so now I'm just going to mark this with different tick marks using a different color. Well, now since those base angles are congruent, I know that KH has to be congruent to KJ using my tick marks there. And that is all we have for isosceles. Let's go on to another example. Let's talk about equilateral theorem. Equilateral, remember, equilateral triangle, all the sides are congruent. And basically they're saying if an equilateral triangle, if the triangle is equilateral, saying all the sides are congruent, then if, then all the angles must be congruent. And the opposite or the converse must then be true. The equilateral theorem also says if the angle is equiangular, so if equiangular mean all the angles are congruent, then the sides have to be congruent. So one starts with the sides and one starts with the angles, come to the same conclusion that they all have to be congruent if the sides are then congruent. Let's try this out. If we want to see is the triangle equilateral or isosceles, and solve for x. Well, here I notice all the angles are congruent. We're dealing with an equilateral. And an equilateral means all the sides have to be the same. So x has to be 12 because they all have to be 12. Number 2, let's look at number 2. Oh, only 2 of the angles are congruent. We're dealing with an isosceles. And that means these two sides, they have to equal. So you just set them equal to each other. So 3x plus 2 must equal 24. We're going to solve. First, distribute our 3. Make that solve for x by subtracting 6 to both sides. 3x. Bring this down. 24 minus 6. We get 18. Divide both sides by 3. X should equal 6 right here. Let's look at number 3. Ooh, we only have 2 sides are congruent here. This one is a tricky. I know that these 2 base angles have to be congruent. But that isn't a base angle. But I know with my other theorem that they all have to add up to 180. So 180 minus 130, that gives me 50 degrees. So these 2 angles on the bottom, they have to add up to 50 degrees. So just take that 50, I divide it by 2, I get 25. So my base angles must be 25. So we got 25, 25, and 130 degrees to make a full triangle of 180 degrees. This bottom one, we have, oh, this is, by the way, this is an isosceles. This here is an equilateral because all the sides are the same. If all the sides are the same, I know that it all has to add up to 180 degrees. Divide that by 3 because there's 3 sides. That gives me 60 degrees. X needs to be 60 degrees. Down here I have all 3 sides are the same. Ooh, I'm dealing with an equilateral because all the angles here are all the same. We got 3 angles the same. If I want to solve for x or y, well, let's try to figure this out. I know that my 8y has to equal 40 because all the sides are the same. Divide by 8, divide by 8. Y must equal 5. So here, y equals 5. And that's, if this is 40, this also has to be 40. The distance here is 40. Ooh, and since this is 40 and this is 40, I can guarantee these 2 sides are 40. I'm dealing with the angles have to be the same. So these 2 angles down here have to be, so I'm dealing with an equilateral is the first one and an isosceles. Dealing with equilateral and an isosceles. So this is 40, this is 40. I know this here is a straight line. This has to add up to 180 degrees. If one side equilateral, we already proven that one angle of equilateral has to be 60 degrees. So I know these have to be 60 degrees. So I'd take 180 minus 60 will give me this vertex angle on the top. That gives me 120 degrees. So this is 120 degrees. And then I know that I can subtract that 180 minus 120, and that should give me the sum of the 2 base. That says 60 degrees. So I take that, the 2 bottom to add together have to be 60. So I take 60. I'll divide that by 2. x should equal 60 divided by 2, we get 30 degrees for x. Y is 5, x is 30 degrees.